When the sleep centers are not activated, mesencephalic and upper pontine reticular activating nuclei will no longer be inhibited. This in turn excites the cerebral cortex and the peripheral nervous system, which will then send numerous positive feedback signals back to the same reticular activating nuclei to activate them further. Therefore, once wakefulness begins, it has a natural tendency to sustain itself because of the positive feedback mechanism. After the brain being activated for many hours, neurons become fatigued. Consequently, the positive feedback cycle between the mesencephalic reticular nuclei and the cortex fades. The sleep-promoting effects of the sleep centers take over, leading to transition from the wakefulness state to the sleep state. Stimulation of several specific areas of the brain can produce sleep with characteristics near those of natural sleep, such as the Raphe nuclei in the lower half of the pons and in the medulla, which will secrete serotonin. Stimulation of nucleus of the tractus solitarius, rostral part of hypothalamus and diffuse nuclei of the thalamus will also produce sleep. There are two types of sleep that alternate with each other. They are the slow wave sleep and the rapid eye movement sleep, which is also known as the REM sleep. Most sleep during each night is of slow wave variety. REM sleep, on the other hand, occurs in episodes during sleep and occupies about 25% of the sleep time. Each episode normally recurs about every 90 minutes. Slow wave sleep is also known as the dreamless sleep, although we still dream during slow wave sleep, but the dreams are usually not remembered. Slow wave sleep is exceedingly restful and is associated with decrease in peripheral vascular tone, blood pressure, respiratory rate, and basal metabolic rate. REM sleep lasts about 3 to 5 minutes and usually appear on the average every 90 minutes. When the person is extremely sleepy, each REM sleep is short and may even be absent. Conversely, as the person becomes more rested through the night, the durations of the REM greatly increase. REM sleep is usually associated with active dreaming and active bodily muscle movements. During REM sleep, the person is even more difficult to arouse by sensory stimuli than during deep slow wave sleep. The muscle tone throughout the body is exceedingly depressed during REM sleep. Heart rate and respiratory rate become irregular during REM sleep and is a characteristic of the dream state. Despite the extreme inhibition of the peripheral muscles, irregular muscle movements do occur, which result in rapid movements of the eyes. During REM sleep, the brain is highly active and brain metabolism may be increased by 20%. Lack of sleep will cause progressive malfunction of the thought processes and causes abnormal behavioral activities. In addition, a person can become irritable or even psychotic after forced wakefulness. Therefore, we might postulate that the principal value of sleep is to restore the natural balance among the neuronal centers. A restful sleep ensues, arterial blood pressure falls, pulse rate decreases, skin vessels dilate, increase activity of gastrointestinal tract, skeletal muscle fall into a mainly relaxed state, and basal metabolic rate of body falls by 10 to 30%. Sleep is vital for our physical well-being and our mental health. So to think twice the next time when you decided to stay up late to burn the midnight oil.